So, hi everyone. Welcome to this session on the Visual Studio family. I would like to thank you for choosing to invest the next hour of your lives in this room here with us. We hope you get a good return on that. My name is Daniel Moth. I've been at Microsoft for just over 10 years. I've been on a few teams, more recently the debugger and profilers team, and I've only been on the C++ team since January. So I'm very new here. And that is why my team didn't trust me to give this talk on my own, which is why you see me, the new face, the new guy, but you've also got Steve, the old guy.
Not so old. Not so old.
How long have you been around?
So I've been on the C++ team for 2 years exactly. I know this because my very first day on the job, the week was the week of CppCon. And so there was like nobody there, which was really concerning. So the next year they let me come in and do the talk here at CppCon. And so actually I think you're only about 9 months in, so are you sure you're up for this? Yeah.
Well, obviously I'm not, that's why you're here, right?
I'll keep an eye on it, don't worry.
The way we've kind of split this session is Steve will do all the demos, I will do all the slides, and Steve will also take all the questions, so you better have some good ones for him. So since I'm doing the slides, you can, go take a seat or something.
I'm not worried they're going to have questions. Yeah.
The reason we split it this way is because originally, I don't know if you can tell from my accent, I'm from Greece. And in Greece, we have a characteristic, we can speak really fast. So this is good news for you because I can pack a lot of content, a lot of slides in this 1 hour. So that's what we're going to do. If as I fly through those slides, you kind of miss something, don't worry, because you just need to write down this URL, which is our blog. And we will upload the slides to that blog later on. And during the slides, there'll be a whole bunch of URLs, pointers to various things. So you don't have to write all of those down, just write this one down, and then you'll get everything in one package. So how have we structured this talk? We've structured it in 3 parts. So in the first part, we will talk about what we call the toolset. So that'll be the compiler, the front end, the back end, the linker, the libraries, that whole package. And we'll do that in about 15 minutes just using slides. Then we'll go to the second part, which is all about the Visual Studio IDE and the Visual Studio Code editor. And that will be the meatiest, the largest part of the session. And that's where Steve is going to do most of his demos. And then after that, we'll get to the third section, which will be the shortest, where we'll look at what we call workloads, which is basically the scenarios, the types of apps that you build, the types of platforms that you target, and just see what's new specifically to those workloads. So that's kind of like how we're thinking of doing this. Does that work for everyone? Can we proceed on that basis? Good, because that's the only talk we brought. So before we get started, though, I do have 3 targeted advertisements or advertisements, depending on your upbringing. So these 3 ads, they're targeted, so you should like them. So first targeted ad. Now, as you probably know, we don't have a great library acquisition story on Windows. Like package managers and things like that you may have seen on other platforms, which is why we're experimenting with a solution on GitHub. So you can go to github.com/Microsoft/VCPKG for VC package to use this or even join and contribute. This is a completely open source project. It has nothing to do with our compilers or our Visual Studio or anything like that. It's applicable to any C++ project on Windows that depends on third-party libraries. We just announced this today, I think. So go check that out. This is also a good time to mention that tomorrow, Tuesday, and on Wednesday, we will have a Microsoft booth, basically a table out in the hallway, where you can come and ask questions about this or anything else that we're doing at Microsoft. So second targeted ad, this one speaks for itself. If you go to aka.ms/CppCon, you'll be able to take a developer survey for a chance to win an Xbox One S. We will, physically, literally give that out this week here at CppCon at the end on Friday. So please go and take that survey. We do developer surveys all the time, and we do those so we can improve our products for you. So even if you don't care about the Xbox, please go and take the developer survey and help influence our direction to where you think we should be going. And then the third and last slide that I'll put up before we get into the talk for real is a list of the other talks that we have here at CppCon by members of the Microsoft team, which are these up here. Now, as you know, we participate enthusiastically. We invest heavily in the C++ standards. We send, around 8 people to each of the 3 meetings every year. We review proposals. We make proposals. We implement early proposals in our compiler to validate that they really would work with large code bases, and that's our duty since we represent such a large percentage of C++ developers as users of the compiler. And all of that is reflected in the talks that you see up there on tuple or modules, coroutines, and so on. We also make contributions to the libraries. If you were in the keynote, you heard Bjarne talk about, for example, the GSL, the Guideline Support Library. We make significant contributions to the proposal and the public repos for Range v3, which is what the Iterator Haiku talk is about. So that's kind of like the kind of talks that you see here. And in fact, if you look at all of them, except for the last one, all the others have nothing to do with any Microsoft products. This is purely just participating in the community and the standard. The only one that has to do with our tooling is the last one, which is the one that you're in right now. So let's go and talk about our tooling. So by a show of hands, maybe an obvious question, but how many people here use the Microsoft Visual C++ compiler, MSVC? Okay, you don't use it, James? Okay, I'm just checking. All right. So that's most of you. So you probably want to know how we're doing on our primary goal, which is to achieve standards conformance. So here is a slide with a bunch of green boxes, which is the progress that we've made towards standards conformance with Visual Studio 2015 RTM, released to manufacturing, which is the release we had last summer. And Steve was here last year talking about all of these. So if you're not on Visual Studio 2015 RTM, this is what you're missing out. So you should go to the latest so you can get all this. But we haven't sat still since then. We have released, since that time, Visual Studio 2015 Update 1, VS 2015 Update 2, and more recently, Update 3. And usually we do the majority of the churn of the features in the RTM version, but actually even in the updates, you'll see from the blue boxes that we're making progress towards that standards conformance. Now, beyond the updates, we've also released previews of the next version of Visual Studio, the one we're temporarily calling Visual Studio 15. And after all the previews are done, then there'll be a release candidate, an RC, then an RTM, and then updates, the usual Visual Studio wave. So you should be delighted to know that as part of that Visual Studio 15 wave, we're going to go and tackle all the orange boxes that you see up there across C++ 11, 14, and 17. So wherever you see two asterisks, that means that you have to throw the C++ latest compiler switch, which we've blogged about and which I will touch on the next slide. So in case it's not clear, the big deal here is that we're communicating that next year we will be standard conformant up to C++ 14 plus more, as you see up here on the slide. So that's pretty good, we think. Now, what we don't have here on the slide is C++ 98. Because I couldn't fit that on the slide, so I left it off. No, on a more serious note, we know that you care about the two-phase name lookup feature from C++ 98. I'm seeing a couple of people nodding, and a few people nodding off as well. So, with C++ 98 and the two-phase name lookup, we're trying to get there with what we call the compiler rejuvenation, where we're trying to modernize what is a very mature code base using an AST-based parser, and we're excited to announce that we will actually, I could fit that up there, get two-phase name lookup as well in here. So, Steve, you said they would be more excited with this. It's like, no, if we have to beg for it, we don't want that. So you can see that two-phase name lookup has one asterisk on it. It's kind of like, raw eggs that you see on the menu where they have the asterisk. No, it doesn't matter. I'll keep them to myself. So the reason it has an asterisk is because you have to use the permissive minus switch. So let's talk a little bit about that. So this is basically a compiler option that puts the compiler in a mode where it will honor and enforce all pre-C++ 11 standards. Of course, that has the side effect that it can potentially break all C++ templated code, which is why it is off by default. So we need to give a chance to the ecosystem, including all the code bases, but the public headers, the open source libraries, to catch up with the idea that the Microsoft compiler does not enable by default all the Microsoft extensions and the Microsoft-specific behaviors. We do want to turn it on by default at some point, and until that point, we will continue adding to this mode. This is good because this allows you to upgrade without fear that by default we will break your code, while putting you in control at the pace at which you want to update your code and go and flip the switch for you. So in that kind of theme of switches, we also have the standard C++ 14, which is on by default, and that will give you the latest standard. And we don't have a switch for C++ 17 yet because that is not finalized yet. But we do have the standard C++ latest where we implement the technical specifications and anything that is not part of a finalized standard. So we're talking about this, all this conformance. What is the impact that has? Well, beyond your own code bases, you also rely on libraries. So one measure is some libraries that previously couldn't work with our compiler and now can. And we've got some examples of those coming up on the slide. Now, the reality is that some large cross-platform code bases have implemented workarounds for our compiler because of our conformance gaps. So now as we're catching up with conformance, we're going and working with those library owners to remove those hacks. The canonical example being Boost, where they had no less than, 6 pound defines. And as you can see on the slide, we're removing 4 of those. If you're curious, the other 2, one is on two-phase name lookup that we touched on, and the other one is mapped to a few bugs that we will fix by the next version of Visual Studio. So that's kind of the conformance portion, if you like. So now that we're catching up to that, we're also looking at what other investments we want to be making in our compiler, such as code analysis, but also compiler diagnostics, so fixing, improving the compiler errors. So you're seeing 2 examples up there of the diagnostics caret, which allows you to see not only what line the error occurred on, but exactly which column, so you can pinpoint exactly where the issue is. Now, we're not sharing this as some huge milestone or innovation. This is purely to indicate to you the direction to which we're going to start and going next, and I hope you like that direction. Now, switching gears from the kind of front-end compiler more to the back-end on code generation, we have blogged in depth and actually did the Channel 9 video on Going Native as well about the new SSA-based optimizer. And what I have here on the slide, other than just making you aware of it, is an example of the code size savings you can have with code before and with and without using the new optimizer. Of course, you care about not just code size, but also code performance. And we're seeing some early wins in some parts of some benchmarks that we're sharing up there. This will be an area we're going to invest more heavily in the next release of Visual Studio. So you should expect to see more there. Moving from performance to reliability. We have what we call the real-world code examples in our labs. These are really large code bases that we build every single day after all the check-ins go in to validate that we're not breaking anything. And the first bullet that you're seeing up there with Windows and so on is kind of what we've traditionally been using, which has been very good for us. But now with the second bullet over the last year, you can see we're adding more from the community, more open source code bases in there. So this has 2 positive effects. One is it makes our compiler more reliable and more robust. The other, as I mentioned at the top of this talk, we do implement early proposals to the standard. So this gives us a good way to catch any down-level unwanted side effects. So this is all goodness. If you have a real-world code, large code base that you think we should be including, let us know and we'll consider that as well. And then finally, how many people here turn on the control flow guard option? Yeah. So that's actually 4 people. That's not a half, it's 4. Well, all of you should. So this is a security feature, helps mitigate attacks in your code. All of Windows builds with this turned on over the last years, and it helps a lot. We've done a blog post in depth if you want to go and look at it. All I wanted to signal here is that we continue to invest in secure code generation. And then the last slide here is going to be about build throughput, which we know you care about. As you go and work daily in your edits and build debug phase, you want that building phase to be as short as possible so you can be more productive and churn things faster every day. So we have done improvements in our front end and our back end, but the improvements you're going to feel the most are in the linker. You can get there gains of 2 to 4x in that linking phase, which dominates when you build in, when you just edit something and build again before you debug, but using specifically the debug fast link option. So that is off by default in Visual Studio 2015. So go turn that on in Visual Studio 2015 Update 3 and see what gains you get over there. And then the good news is that with the next version, with Visual Studio 15, we're A, turning on by default, so everybody will feel that. And then B, we're actually improving another 30% on top of those gains. So this is really good stuff. This is performance difference you will feel. Now, beyond what we are doing, we also have partners that work with us in this space. One of them is Incredibuild. And Incredible, they sell these extensions. So Incredible has this extension that improves by 10-20% across the board all build throughput by parallelizing the builds. And the good thing here is we've negotiated a deal with them where you can get a free version of their extension, with the limitation being it only uses 8 cores. So if you're okay with that limitation, I cannot imagine why you wouldn't go and try this and see what it does for you. It's free. So with that, we're kind of at the end of that first section that we talked about with the compiler tools, and we cheated a bit, especially with this slide, because we're starting to touch on Visual Studio things. So let's go here and transition from out of that into Visual Studio. So we do have time for one question if someone has a burning question on what you've seen so far. There's one there and one here. You're not allowed to ask any. So let's go with this one. He's looking at me a very mean way. You're looking in a friendly way. So yeah.
So in my libraries, I like to only require my users to have C++11. So I won't mention the other compiler's name with a switch that only allows C++11. Is that going to be possible in Visual Studio? Only C++11 support?
So the question was, is it possible to take the compiler and put it in a mode where it's only C++11? And I'm seeing Steve, who's supposed to take the question, just shaking his head. You can say words. You're allowed to speak. It's okay.
No.
That was it? No? Come on. Throw him a bone.
Wait, just step. What? Should I have to repeat the snarky answer?
Let's not repeat that. Okay. So you should talk to Steve afterwards and make him make Stefan do it. So I'll take the one down there as well. What was the question?
You mentioned that there was a 2 to 4x speed up with the linker flag. What's the trade-off there, or why is it not on that fault?
Yeah. So if the question was, what's the trade-off there? There was a trade-off in terms of the. Actually, do you want to take that
sure.
as well?
Okay. So the binaries, they're no longer, you don't ship the fast link binaries. There's a tool on there called MSPDB CMF. You need to use that to convert them into to full link binaries before you ship if you want to keep those symbols around. That's the trade-off. It's why we didn't do it at first. Now we have kind of more of a developer experience around being able to do that.
So the trade-off on your actual inner loop as you develop every day, there isn't one. It's only when you were going to move the PDBs, and now we think we've solved that to an extent. All right. So thanks, Steve. So back to here. So now we'll transition to looking at the Visual Studio side of things. And before I go and jump into the Visual Studio IDE and the Visual Studio Code Editor, I did want to make you aware, in case you're not, of Visual Studio Team Services, VSTS. So those are our cloud-powered developer services that give you things such as source control, version control, work item tracking, project management, continuous integration, Kanbans, dashboards, that kind of stuff. The developer services that are really agnostic of whatever tool you use and what platform you're on, or even what programming language you use. So if that's something that interests you, you can go to visualstudio.com and learn more about it, because we're not talking about that in here. And you should know that's free for individuals and for small teams. So that's something to go look at. So now let's look at the Visual Studio IDE. So like I said earlier, we shipped Visual Studio 2015 RTM last year, and Steve was actually here with my predecessor, Ayman, and they did a talk about everything that was new in that. And as I also said, we do ship most of the value in a new release in the RTM version. So if you're not familiar with what's in that version, we're not repeating that today. You should go to the YouTube and watch that session. What we're going to talk about today is only the delta. So what is new in the updates. Update 1, update 3, and also what is new in Visual Studio 15. And here are some of those things. I'm not going to read the slide. I will always trust in your ability to read slides, so you won't see me reading all of them. So here we have 2 buckets. There's the bucket of things in Visual Studio 2015 in the updates, but then there's also the stuff on Visual Studio 15. And the ones we selected to put up here, this is not release notes, it's a selection, are the ones that are under what we call the productivity bucket, the things that make you more productive every single day. So rather than talk about these, Steve is now going to actually go and demonstrate those to you.
Bam. Okay, great. And I'm on. All right, so first thing I want to stress, this is a pre-release of a pre-release build. I am running a developer build here on this box. This is upcoming build, Preview 5, which should come out in the next few weeks or so. What I have here is, I want to show you some of our productivity features, the ones that were on the slide just there. The first thing I want to show you is what you can use to navigate around inside of your application. But before I do that, I want to really quickly just show you Alt Tools options. And if you come in here and you type experimental, it's going to bring up this property page where all of our sort of our more experimental things are. This is the kind of audience of people who like to go and try new things out. Please go set all of these to true. I would really appreciate it, and give us your feedback once you get your hands on these bits. First thing I want to show you here is what we call the new go-to experience. So I'm going to push Control, comma on my handy-dandy keyboard, and I'm going to get this new thing that looks like the old Navigate to. This is new. I'm going to type question mark, and it's going to give me some help. This is a very keyboard-friendly experience, and it's going to teach you how to use it. So I'm going to come in here. First thing I'm going to do is not that exciting. I'm going to go 155, really quick jump down to that line. Once again, oops, Control, comma, back up to where I was. Okay, so that's go to line, right? The next one I want to show you, Control, comma, I'm going to type F for file, space, DLG. So that's going to very quickly bring up a list of all of the files that have DLG somewhere in them. And as you can see, this is an MFC app, so it's all the dialogues. If I go on here and I like single click on this one, you can see it'll open it up in the preview tab. I also want to show you that there's actually a ton of configurability in here. I can choose where I want this window to be. I can choose whether I want to use the preview tab at all, but the go-to file thing is a very fast navigation tool. Don't have to take your fingers off the keyboard. Next thing I want to show you is if I come back up here, I'm going to type a keyword that's all over the universe. So let me type event, which is way overloaded in this code base. So I've got a bunch of other filters down here. One of them is types. This is going to narrow the list down to classes, structs, and enums. This one over here is members, so that's going to be like enum items, fields, methods, etc. And then this is symbols. Symbols is going to be types plus members plus any other language constructs. The main one is macros. So that is our new Navigate to experience. It's fast and fluid. It's super fast. The next thing I want to show you, once I get back to my thing, escape. All right, here we go. So the next thing I want to show you is our significantly improved find all references experience. So as I go here, I chose find all references on this. And as you can see, instead of the old dialog, we have a whole bunch of improvements here. First thing I want to guide your attention to is the grouping. You can group by project, you can group by path. And so this is really useful once you get a lot of number of items in here and you're trying to go through there, maybe some large scale refactoring that you're doing. Another thing this is really useful for is any kind of code analysis, fix all the warnings kind of situation. We've got here the read-write column, which will tell you if it was a read or a write or an other. We actually also have the ability to click here on this little filter icon, and then you can say, only show me the reads. So this is, it's very configurable. It can be used in a lot of different scenarios. Another thing I want to stress about this, and this is going to be a theme overall, is raw performance. We're bringing events in, or we're bringing results in incrementally here. It should be much faster for large return sets than what you were seeing previously. Okay, so that's navigating around your code, some new fun things. The next thing I want to take you to is some authoring stuff. So now I'm going to type some code. So the first thing I want to do, int I equals size. Okay, great, IntelliSense, wonderful. So what I have turned on from those experiments is something we call predictive IntelliSense. And so because I typed int I equals, this has already narrowed down this list to only things that could realistically be ints. And so you can see when oops, let's do that one more time. You can see all the ones that have the word size in them, and also it's actually not that big of a bar if you take a look at the scroll bar. I can also go in and do the same kind of filtering here that I did in the previous view. I've got narrow it down to just variables or narrow it down to functions. And if you do want the old experience where we're not predicting in case you're doing something cuckoo, you can do this or Control J. Again, we love keyboards too, to get the full list. And that can give you, if you looked at how much the scroll bar changed, it gives you a sense of just how much filtering we were doing for you. Okay, so that's predictive IntelliSense. It's really neat. This one is super small, but sometimes it's the little things that help. So here I am, I'm going to type p font assert. Wait, dot? Wait, what? And then I'm going to select that one, and it automatically translates it to an arrow. So that's cool. So this is like, it's not going to change world peace or anything, but now, we're doing what you meant, not what you said. This is the beginning of the AI taking over and destroying the world, but you were there on the ground floor. All right, so that's fun. Here's another super fun, tiny one, which is I'm going to go in here, I'm going to select these, and I'm going to type the left brace. and then I can very quickly kind of, oh, really? All right. Okay, that was not the one I thought was going to get the woo. But that's fine. All right, cool. That's okay. I can't predict customers at all. It's all okay. It's great. I'm going to select this. Okay, so you're going to remember the control comment thing, right? Okay, so right next to that on your keyboard is the dot key, right? So control dot. We've significantly improved the light bulbs. We have more refactors, and in particular, extract function is a lot better than it used to be. We've got the ability, extract as free function, as member, put it wherever you want it, give it a nice name. This is all stuff to initialize a tooltip. Hit enter. It'll go do some IntelliSense, make sure it makes it an accurate one. Opens up a preview tab so that you can peek into what it did and it replaced the code. So I'm going to back all that out. And I am ready to show you some debugging. So let's transition out of that. I'm going to do a build. And then we're going to want that. OK. So, all right, this thing actually builds a help file every time. Sorry. Internet code. It's actually really cool. It's a Famicom tracker, so you can make beeps and bloops like a good old NES game. So here we go. I'm going to start up the debugger. So the first thing that you're going to notice now that we're transitioning into diagnostics is the diagnostics tools window is going to open up there. And actually I have to hit my breakpoint. I'll go in here. I set one in the about box to make this easy. You see how it says it's preparing threads up there? And this is the CPU profiling thing is set to on. So we've been doing this diagnostics tools thing. This is our sort of second version with it. And we've continued to move more and more of the cool beyond debugging stuff into the debugger. And here you can see, while I was chatting there, we brought up sort of a function list here. Right now it's sorted by the total CPU time. In other words, how often that function was on the stack. But I can actually even come over here and sort based on self CPU. So this is how often the body of this function was on there. So that's kind of neat in and of itself. So if you've ever used the Visual Studio Profile, that's my first product here at Microsoft. I'm going to click on here, and it's actually going to take me to the butterfly view. So I can really start drilling in on the performance of my code without even having to leave the debugger. So I can see what this function did and the functions that called it. You can see we've got just the beginnings of starting to color the actual function body itself with the hotspots. So we think this is going to be really useful. You can also come up here, hit call tree, and drill down into the call tree, do kind of a top-down performance investigation. And so yeah, the profiler right there inside of the debugger. So that's great. So the next thing I want to do is show you, this is another little one, I like these. So if I just hover my mouse just a little bit, it's a little green arrow, and I click on it, bam. So this is the new run to cursor experience inside of Visual Studio. If you like that and you didn't know we had it in the old versions, when you go back to those of you who are still not using our pre-release product, if you go in here, there's actually, it's always been here, but people didn't find it. So now you can find it. It's awesome. So okay, one last thing for the productivity stuff. So I got this struct here, right? And I'm going to initialize it, and then I'm going to go ahead and set one of the fields to 10, and I'm going to step one more time. But you know what? I didn't actually initialize this thing properly, so it's not going to work. So bam, we get the new exception helper UI. And there are two cool things about this. Three. I actually like the UI, it looks prettier. But the other one is, it actually tells you for read access violations, which part of this cascade of pointer derefs is actually the null pointer. So you can see it says a.pb was the null pointer, which I think is definitely going to save you some time. Okay, so now this is another one, I get to ask you a question kind of moment. So who's ever had to use a third-party library where the kind of the jerk who wrote the third-party library likes to use exceptions as control flow? Does that happen? Okay. Well, look, nodding, and yes, you've all done that. So I want to draw your attention to this edit conditions thing, right? I'm going to click on that. And so what this allows you to do is set conditions on your breakpoints and say, if this is that jerk's DLL, no, don't break, keep going. So I think this is in and of itself going to save man-years of time. All right, Daniel, you're up, buddy.
Cool.
If I can find the button.
You guys like that?
Yeah.
Awesome. So that was Visual Studio 15 and showing you some things that are also in Visual Studio 2015. We're going to come back to Visual Studio, but let's take a small diversion towards editors and Visual Studio Code. How many people in here have not heard of Visual Studio Code before? Can I see? Show of hands? Not. Okay, no one wants to admit it. Oh, a few people do. All right. So for everyone else that has heard about it, and for the people that haven't, when we released this a couple of years ago now, people thought it was Visual Studio that now also runs on Linux and the Mac. So I just want to dispel that myth. This isn't the Visual Studio. It's not an IDE. It does run on Linux and the Mac as well as Windows, but it's an editor. It doesn't have like a tenth of the capabilities that you would find in Visual Studio. It is not meant to. It is an editor. But for an editor, it is amazing. It has built-in Git integration. It has debugging support. It has extensibility. You can go and configure text files to kind of compose your own inner loop with command lines and so on. So it may not be an IDE, but it's a really great editor. So it's kind of aimed at if you don't want to use Visual Studio, I mean, if you're crazy, I don't know, if you don't want to use Visual Studio and you have more of the upbringing, the developer upbringing of the Vim or Emacs or Sublime, something like that, then this is the tool you need to check out. And if you go and download Visual Studio Code, you will want to also get our C++ extension, which actually gives you the full C++ experience in Visual Studio Code. So instead of talking about that experience, Steve now is going to go and demo it. Steve, over to you.
All right, so I've got Visual Studio Code open here. So the first thing I want you to do, it installs really quick. It's like a 2-minute install. It's really tiny. Go ahead and get it installed. Once you do, and I will tell you, I found out, Daniel, while we were practicing, that this actually uses the network. But so if you go in here and you type CPP, C++, and click Enter, and you have working Wi-Fi, go ahead and pick the one. We should be on top, but the one by Microsoft, that's the one we wrote. So that's how you get started. All right. So then once you have that installed, the next thing I want to do is I'm going to go to Open Folder, and I'm going to select this. This is the CPP REST SDK that we ship, and this is a very simple application that uses it. So I'm going to select that folder, and what it's going to do is it's going to open up sort of a folder view of what's going on there. As you can see, it creates a .vs code file when you do that, and that's where all the configuration information goes. So I'm going to start up, I'm going to open up my CPP file, and you can see almost immediately I get a pretty good result in terms of coloring. And I get these green squiggles, and hey, include files are not found. Well, you know, you got to tell us something, right? So I'm going to click on that, I get a light bulb. I'm going to click on that light bulb, it's going to say add include paths to settings. Now I'm going to go ahead, I'm going to not type in front of you because I am a bad typer. I'm going to go in, I'm going to pull oops, you see, I'm not even really that good with a mouse. Like, managing though, that good. Okay, you can see you get a different one for Mac, Linux, and Windows 32. I'm going to come in here, I'm going to add in the include path, I'm going to hit save, hope I did that well, switch over back to this file, and now if we give it a second, it should, there we go. Okay, and it'll color it up. And so now it knows about the include path. We're going in the background, and the reason it took a second there is because it's actually doing background compilers and all that good stuff, or tag parsing in this case. And everything that you would expect to work works. So you can go in here, string T, you can do peak def on that, and it'll bring you a peak window just like you get in Big Brother Visual Studio. It's probably a bad way to call it. You know, if you come in here and you do client dot, you will get autocomplete. You know, we'll continue to work on the accuracy in these, but right now it's nice and it's fast. Okay, so that's editing and navigation. Next thing I want to show you, I'm going to push, because I've trained on Visual Studio, I'm going to press Control-Shift-B to build. And it's going to say, no task runner configured. So I'm going to click Configure Task Runner. You can see it gives me a bunch of choices, and again, there's a very large extension gallery already for this tool, so you don't see what you need up here. But I'm going to go ahead, I'm going to pick the MS Build one. It's going to open up yet another helpful JSON file that we can then put information into. This one actually don't have to change. I actually launched Visual Studio Code from the developer prompt, and so all my tools are already in here. I'm going to build. It's going to bring up an output window. It's beautiful. It's lightweight. The build works, and I'm excited. And I'll be even more excited when it's done. Come on. Split fast link. That's the key. Now, all right. So the next thing we're going to, there you go. There you go. All right, so it worked. So the next thing I want to show you really quickly is the debugging experience. Yes, there's a debugger in here. So I click play, and once again, it prompts me. So there's a couple of different environments here. Ironically, we actually did the GDB LLDB one first, but in our most recent monthly build of the C++ extension, we actually added Windows, so I'm going to demo that one today. So I'm going to click that. It's going to bring up oh, hey, you need to set up one of these launch configurations. Everything's JSON files. All right, and so you can see I've got a launch configuration and attach configuration. And I still don't like typing, so I'm going to come over here and I'm going to take, all I have to tell this thing really to get it going is the name of the program and the arguments to pass to it. So I'm going to do that real quick, and I'm going to push, F5 will work, but I like mice too. It's gonna go up here. We're gonna hit the breakpoint. We're gonna get data tips. It's beautiful. This is the same underlying workload, or the same underlying debug engine that we use inside of Visual Studio, just shipped for VS Code. It's lightweight. If I go to the next breakpoint and step once, you can see We've got NAT visualization, native visualization works here. So it's a lightweight editor. I realized I skipped a quick demo, which is we actually just included the ability to do formatting as well. So you can go in here and use, it actually uses claim format on the back end. Hey, hi, to work. And yeah, so that is Visual Studio Code.
Great.
Daniel. Oh, thank you.
I didn't need to prompt them this time.
Right?
They're learning.
They're trained.
So that was Visual Studio Code. Again, you see it has kind of a little bit of everything. It's not a full IDE. That's the point I was making earlier. So with the debugging, for example, it's nowhere near the richness of what you saw earlier. But for an editor, we think it's fantastic. We hope you like it too. We'll continue investing here to make it be the best editor out there. One of the things that we do like about editors in general is that they're fast and lightweight. So talking about performance, what are we doing in Visual Studio 15 on the performance front? So there's a couple of things. Hopefully you're all configuring precompiled headers so you can help us give you faster IntelliSense and navigation and so on. But in the cases where you don't want to or can't, we now kind of do that behind the background for you so you can get that performance. So if you are in such a situation, try with the latest version of VS to see if it's improved your life. The other one is that in some cases with debugging, memory would grow. And we had one pathological case like that of a real app that we were working with. And unfortunately, it would crash after you were debugged after some point. And now we've kind of contained it to be under 2 gig while debugging. So if you had scenarios where you felt, when I'm debugging, memory kind of goes out of whack, try the latest version to see what's going on there. And then finally, we've done some dramatic improvements to solution loading. So here you can see someone has a solution with 1,700 projects. That's Chromium, by the way. And we've taken that from 76 seconds to load after the first time that you've run it down to 15. And that is what we mean by dramatic improvements. In another case where there was one large starter project and 23 smaller ones, that's the Unreal Engine. In that case, we've only improved it by 100% when you load it after the second time. So again, like I was saying with the build throughput, this is performance you will feel. Now the other thing that we've done, following on from the VS Code demo, is the ability, what we call open folder, to point Visual Studio to a folder and have it work with that code. And if in there you also have a CMake file, we will actually parse that and give you an even richer experience in Visual Studio. So we've got the beginnings of that. We just started working on that. So Steve is going to demo that, and when we come back, I'll talk about acquisition and installation experience. Steve, over to you.
Okay, so as you saw when I was doing that VS Code demo, right, I just went in and I did open folder and I pointed it at a folder, right? Wouldn't it be great if you could do the same thing inside of Visual Studio? So I go in there, I select open folder. I'm going to go in here, I'm going to pick just a folder. This is Ecstasy is a random algorithms thing we got off the internet. It is not, there's no project file here, there's no CMake. It's just like the VS Code demo, it's just something we're pointing at. So what I'm going to do is I'm going to wait in there and see it sort of scanned, notice that it was there. When I come in here and I open up one of these files, if I give it a second, it'll actually color. Once again, if I come in here and do our beautiful new find all references experience, it'll work. And so how does this work? So again, it's JSON files all the way down. So I'm going to show you, let's use goto, control, comma, and I'll do F CPPP. And you can see we've got this CPP properties.json file. And it looks, go away now. Whoa. Okay, CPP, control, comma, F space, CPPP. I'm secretly actually a mouse guy, guys. Okay, so you specify the include path, you look at the forced includes and you add the pound defines and it's enough. That's how we're able to go and do that. Now we're going to keep going forwards on this and add the other kinds of experiences that you would expect, like the ability to tell it how to find the right place to debug, etc. But that's just if you have sort of random code that doesn't have anything. But if I switch over to this other Visual Studio and I go to open folder and I pick that other folder that I had on the demos, the CMake one, I'm going to get an even better solution. So this one is, basically every time you go open folder, it goes and it trolls through the folder that it's opened and looks for sort of these magic files, right? There's cppproj.json. If it sees that, it does what I was showing you before. But if it finds that there's a CMake lists.txt file, it will go in and, now we've got enough information without you modifying anything to go in. And again, the colorization happened. I'll come in here, I'll find all references again to show you nothing up my sleeve, nothing up my sleeve. Next thing I want to show you on this, though, is this one. This is early UI. This is not how it's going to work eventually, but you can come in here already, click build. It will succeed, and yes, you can right-click on here. If I click debug, and then with a little bit of luck, yeah, we're debugging the CMake thing. So I want to stress, there is no secret background generation of projects going on here. We're actually, using the CMake file sort of natively. We're building on top of some awesome contributions in the community, and we'll make some enhancements to those and then contribute them back in collaboration with like the CMake guys kitware. So yeah, so that's the beginnings of CMake for Visual Studio. I call this like Visual Studio beyond projects. Yes. All right. Okay, Daniel, you're up.
You guys didn't like that? You clapped him before you.
I like the joke. I like confused.
Once you start, you gotta keep going.
I'm addicted.
Yeah, without projects. So it will make it easier for you to just come and try Visual Studio without having to first buy into the whole project idea, essentially. So acquisition, installation experience. If you go and try, so that was the demo. If you go and try and install Visual Studio 15, you're going to see our new acquisition experience. Just curious, how many people have actually tried Visual Studio 15? Just there's a few of you. So you guys may have seen that because it came at a certain preview. I don't remember which one, but it looks like this now. So what we have is what we call a workload-based approach to picking your installation. You can go and choose individual components and kind of do it a different way, but the workload-based approach is what we expect most people to pick. For example, you see at the top box up there, it says the Universal Windows Platform Development. So if you were targeting apps to deploy to the Windows Store in whatever language, you would pick that workload. I have actually picked the one underneath, hence the check mark, which is the Windows Desktop Development with C++. It says desktop, but really it's just to build any binary that will run on Windows, just not specifically targeting the Windows Store. And then when you pick it, here on the right, you can go and fine-tune and customize further within that workload. Now, this is awesome. Why is it awesome? 3 reasons. First, you will actually, your hard disk will thank us, right? You're gonna only install the things that you want, so this will have a smaller footprint. Second, it's gonna be much faster to install, because again, you're picking exactly what you want to install. And third, there's not going to be the visual noise of things that you didn't care about that you just got because it's there with Visual Studio, because you're only picking exactly the workload that you want. So, for example, if you didn't care at all about C#, you just didn't want to see that thing ever, other than here maybe, you pick C++ because that's what you care about, and then you will get the Visual Studio installation for C++ only, the one you've always dreamt of, in under 12 minutes. Right? So I don't know how many people budget for less than an hour to go and install Visual Studio today, but at this point you get that like that fast. Now there is a fourth reason as a C++ developer to like here, which is if you see here in the options, this is where we can and will give you the ability to install all the tool sets. So if you have some project that you cannot move forward from, let's say, the Visual Studio 2013 compiler or something like that, instead of having to install that Visual Studio and have them side by side, you just get the latest Visual Studio, pick the tool set, and then in that project just configure it to target the older tool set. Again, your hard disk will help thank us for that. So that's kind of like the workload approach that we're taking. This is a good segue to the last section that we have, where we actually talk about workloads. And these workloads are in the Visual Studio 15 sense in this installer, but also you can use some of these like the Android iOS with extensions and project types and so on. So again, I think we have probably time for a question if someone has on the stuff we've seen so far on Visual Studio. Yes, sir.
For the workloads, can you save your presets so that your whole team can get the same installation?
I think that. Oh, repeat the question. All right. Can you save the configuration that you had? I don't believe that part has been implemented, and I am not 1,000% sure what the spec is.
But that sounds like an extremely reasonable thing.
Yeah.
So if we weren't planning it, we'll do it.
And in the preview builds, there isn't things like there's no like offline install isn't there yet. These things are coming, but we'll make sure people know. Yep.
We have time for another question as well. Yes.
This might be segueing to the next portion, but as far as the workloads go, is there going to be some sort of workload where you can actually do kind of a generalized cross-platform project that targets any type of system that you want as like a core base?
Okay.
So
We'll definitely. So the question was,
we'll
will
touch
we have
on
cross-platform projects? We'll touch on that a bit in a minute. Do you want to?
I'll take one more.
Okay.
For VS Code, one of the things we were wondering about is the license on the C++ debugger. Is there like any kind of special licensing for that?
If you what?
Yeah, but basically, if you want to use VS Code but debug C++ code and you don't have, say, a full license, then without the license.
So the question is about the licensing with the Visual Studio debug engine that we plug into Visual Studio Code. You can use Visual Studio Code without requiring to do anything else. So I think that's the answer. The Visual Studio debug engine is not something you use directly or that we would expect someone to use directly. You use Visual Studio Code, through that you get access to the engine.
Yeah.
Sure.
I have a question about the use of CMake in both VC PKG and also Visual Studio. It seems like it's being used in VC PKG, and also somehow being used in Visual Studio with the new editor and the ability to generate projects. Is it like something you'll ship along with Visual Studio, or is it something that?
So the question is on the question is on CMake, and basically how do you distribute it? How do you get it? It keeps popping up everywhere. Like, how is this going to work?
Yeah. So when you install Visual Studio, you'll get everything. I don't know if you noticed on his slide there was actually a checkbox for the CMake tools. Yeah.
But Visual Studio is not using CMake to actually open and generate a project.
That's right. No, there's a thing called CMake daemon that we talked to that allows us to answer questions that we need. Yeah. Okay.
All right, cool. So let's jump into the workloads. And this was the section I said at the start. We're going to go very fast through. So first, Windows. Did I ask already how many people deploy to the Windows Store? Have we asked that question? 1, 2, okay, 3? Like just shy, like maybe. So I'll just go through that kind of quickly, the new things that we have in there. There's now a single unified Windows Store where you can deploy a single binary and with that reach all the different platforms, desktop, mobile, HoloLens, Xbox, like everything. And at runtime, that can detect and adjust to the format, the input type, and the actual form factor of the device it is running on. So that's pretty cool. We've also made some advancements here to the Angle open source library if you want to use OpenGL in your mobile apps, both for the Windows Store, but also this accrues to targeting Android and iOS, which is a workload we're going to touch on later on. So that's cool as well. And then what we're doing now is experimenting with a C++ standards approach to accessing WinRT. And there was a talk about that earlier today that Kenny and James did. So if you're interested in that, you should go and watch the recording on YouTube where they went in depth as to how that works as an alternative approach to C++ CX potentially at some point. Now, a lot of you have desktop apps, and maybe from those desktop apps, you want to reach more people by going through the Windows Store. So we have this cool thing called the Centennial Bridge that allows you to package your desktop app and deploy it to the Windows Store. So that's kind of an easy way as a first step to get there. So that's something you should check out if that's of interest. The other bridge that we have is the Islandwood Bridge, which is a project on GitHub, where it allows you to easily port iOS apps and have them run on the Windows platform for the store. And you can then go and advance them further by adding Windows-specific behaviors. And finally, we have this project structure in Visual Studio where you can go and actually share code across any platform that you target. And so we make that very easy to happen, and Linux is coming very soon to that. We haven't added that bit yet. So there's a question still.
Yeah, when you say Linux, is it just Linux or is it like FreeBSD and kind of the Unix-based systems?
So the question was around Linux. Hold that thought when we get to there, and if it's still not answered, bring it up again. So I'm going to switch gears and go to the mobile workload, which is now a workload in its own right for Android and iOS development. And instead of talking about this, there's actually another session. Here it's not done by Microsoft employees, so I don't know what's in it, but I'm sure it's going to be great. So you should go and look at this session, or attend this if you're interested in mobile app development with Visual C++, or go to the URL at the bottom. In a nutshell, for those of you following the story there, because we've started that a while back. We now have support for round-tripping, importing and round-tripping Xcode projects, including support for frameworks and dynamic libraries. And on the Android side, we have now a Java language service that underpins IntelliSense and navigation, and also the ability to debug Java code when you mix Java and C++ on Android. And then finally also support for the Gradle build system. Again, go to the other talk, which I'm sure will go in more depth on these things. Moving on to the Linux workload. So how many people have not heard of, but actually tried our support for Linux development here? That's just a few of you. So if you, and I bet you've tried that in the Visual Studio 2015 with the extension, right? Yeah, I'm seeing the nods. If you go and select the Linux workload here with Visual Studio 15, that will install in under 6 minutes. So that is something that you can very easily go try and to target Linux remotely from Visual Studio. So how that works is kind of how the Linux development works is up here on the slide, but instead of me talking about this, we'll have Steve to do his final demo. So, you know, at the end, you got to really, really applaud hard there. So.
Yes, or I'll cry, I promise. All right, so to do the Linux targeting development inside of Visual Studio, all you need is some Linux. So I've got some Linux here. I've got some Linux running in a virtual machine on my laptop. This is Ubuntu 16 LTS. So I'm going to switch over here. All you need on that thing is, I don't care if it's a VM, I don't care if it's in Azure, as long as you can SSH to it, as long as it's got some build tools on it, because today we're mostly targeting remote build scenarios. And so I've got a rotating cube here. I've got a project here. This is a Linux project, as you can see. And I'm going to go in, I'm going to show you the properties. If I go in here, and I got remote settings, I've got it set up here so it tells where the target machine is. Now to specify where the target machine is, we go to Tools, Options. I'm going to come in here, I'm going to type connection, I'm going to spell it right. Then I'm going to go to Connection Manager. It's as simple as this Connect Remote System dialog. All you have to do is specify the host name, what port SSH is running on, and your username and either a private key or a password. I've already done that. I've prepped this one so that it's talking to that virtual machine. So also inside of the properties file, you can see all the kind of other stuff that we do here. You can see we're using GCC here. We added support for Clang in the last iteration of these tools. We're shipping about monthly on this. You can see you can pick your standard library and that we're targeting GCC remotely. Okay, so that's cool. So because it's not a demo unless I show final references, okay, so we got all, what I did to prep this machine is I simply copied my source code here, and I actually even just mirrored over usr include so that you could make sure that I could actually know where all of the header files were, got that set up, and I'm good to go. You can see here I found all the places this is an OpenGL application, it's gonna spin a queue. All right, so I won't tease. I'm gonna actually launch this. So what's going to happen is it's actually going to copy the source files over to the remote machine, build them there, and then start up the application. And we're about ready to go here. So I'm right here at the beginning. Now I'm going to hit F5. It's going to go, and we're going to watch a cube rotate in 3D on Linux from Visual Studio. Okay, so I'm going to hit Q just to prove I'm not faking anything here. We're going to end up here. It's going to hit a breakpoint back here on Visual Studio. This is cool. We've done this demo a few times, and we love CppCon. It's in our hometown, all this stuff. So we wanted to show one new thing here that we've never shown before. This is the grand finale, so to speak. So I'm going to go in here. I'm going to open up very much Hello World. This time I'm going to go in to my project properties. This time I'm going to go to remote settings. And this time I'm going to point it at 127.0.0.1. All right, did anybody notice this thing down here? This whole time, was it teasing you, right? Okay, so in Windows 10 Anniversary Edition, there is what's called the Windows Subsystem for Linux. And what that is it's not a VM, there's no virtual machine here, nothing up my sleeve. This is an actual image of Ubuntu. I think it's Ubuntu 14, actually. 14.1.4. That's actually integrated inside of Windows. And so all I've done here, you can see I sudoed up some usr spin sshd. So now when I go and I point it at the target machine, what it's going to do is it's going to loop back around and talk to the Windows subsystem for Linux. So I don't know. I hope this works. All right. So this is like me attempting to build suspense. Okay. How's that going? All right. So again, I'm building. So what's going to happen here is it's going to copy that over through there. It's going to copy remotely into it. I've actually installed GDB and GCC and all its friends there. This is the Linux console window, so that you're not constantly having to like flip back and forth between VMs. If you're just doing like a simple console app, you can actually just use it here. So I'll step over the line, and it'll print out locally, hello from console application 11. So we're done. Thanks.
Was that they drop the mic?
Yeah, drop the water.
Cool. So I hope you like that, because Microsoft does love Linux. If Satya says it, I can say it as well. So I got to do the hand thing. I can't mimic that. We've tried. It's not possible. I don't know how he does it. Related to Linux, kind of, in some situations, is the Internet of Things. IoT is kind of hot these days. And when your things are running Linux, everything we showed you just works. So if you're doing kind of IoT development with Linux devices, all of this stuff just works there for you. And we will be adding support for microcontrollers. We're not sure if we're going to add that in this workload with Linux or if we're going to have it separate. We'll see. We're not sure at this point, but we will add support for microcontrollers. And on the IoT front, if you're doing IoT development in any environment, on any platform, these things, it's IoT because of the I, there's the internet, these things are connected. So if you need to be connected to something, you should definitely check out the Azure IoT SDK, which is that URL, which has all the things you would ever need for IoT development for your backend. Moving to another workload, games. So you can see there at the top, Unity has its own workload, because it's mostly C# folks that use that, we think. And then we have the one that I've checked, which is the C++ game development, which includes Cocos and Unreal and DirectX and so on, which you can configure on the side as usual. You should be used to this by now. So if we go and look at that, first I should say, if you're doing game development, again, with any tool on any platform, similar to the IoT, there's a trend with games now where they're kind of using some kind of backend service somewhere, and Azure does have a set of services specifically for game development. So if you're doing game development, you should check out that URL and see if there's anything there of interest to you. If you're doing your game development with DirectX in Visual Studio, then you maybe are looking at the latest DirectX 12, and we've done a bunch of things that I've got on the slide, improvements there in the diagnostics space for debugging and profiling that you should find exciting, so take the bits and check it out. If you're not using that and instead you're working with one of our partners, we are actually still evolving those relationships moving forward. So for example, with Cocos recently, we had a blog post that showed an example of how to use Cocos Target Android from within Visual Studio, so you can go on our blog and read about that. And then Epic for their Unreal engine are actually working on that. They don't have public bits yet. They've got it internally though, working with integrated editing and debugging in Visual Studio. So I thought I'd whet your appetite with a screenshot that we have here. And when this is ready for public consumption, they will talk about it. We will blog about it as well. So that's the gaming workload. And that brings us to the end of the workloads. If there are workloads that we're missing here, because really what we're trying to do is make sure that as a C++ developer, no matter what type of development you're doing, what you're targeting from Visual Studio on Windows, we won't offer that to you. That's what we're trying to do. So if there's something we're missing, let us know. I'm going to swiftly move on given the time, and we'll take questions at the end. I've got this and one more slide. So we've started recently updating significantly our documentation, working with our documentation folks and our PMs and engineers, everybody involved. And we're actually updated that. So if you haven't been to MSDN in a while and you're kind of stuck on some kind of issue where you can't move forward to the latest version, read the documentation. It's actually getting better. And we're also introducing a new repository on GitHub that you can go, which is specifically for samples and upgrading forward. So that gives you good examples to look at. And if that fails, you've done those two steps and you still cannot move forward, we will do it for you. So there is an email address down there, VC Upgrade, so just email that and we will schedule a Skype call with you and we'll have our engineers help you while you're sharing your codes on the screen to actually move forward. We're committed to bringing you forward. I think Bjarne said something like that in the keynote as well. We need people moving forward to the latest in order they can get value from the new things that we're doing. So I hope you appreciate that. And then on the final slide to kind of summarize, I mean, how do you summarize? It's so much that we've went through. There's all these demos, there's all these slides, all these pointers. So I think you guys are going to go away, forget about all this. So I think what I want to do is just make sure you leave with some words. Like if there's just a few words you're going to remember, what should those be? So I'll give you my opinion. I think it should be conformance. It should be productivity. It should be CMake. It should be performance through code generation, performance through build throughput, performance in the IDE, workload-based installation, Windows, Linux, Android, iOS, IoT, games. Then I get sweaty and start shouting developers. But it's funny, developers, Balmer, those were the days, right? No, but actually on that point, I hope you guys are sensing the kind of the change. We're in the community, we're listening, we're participating, we're collaborating, we're contributing. Who would have thought a few years ago that we would release a free cross-platform editor like Visual Studio Code and open source it afterwards? I mean, nobody would have thought about that, right? I don't know who would have thought about us talking about and encouraging you to use Visual Studio to target Linux and doing that by connecting to home. I mean, these are things that we on the inside as employees of this company are really enjoying, and I hope you guys are as well. So there's always more we can do. So please do email me if you have suggestions what we can do for the C++ community in particular. My email is steve.carroll at No, you can email Steve, but you can email me, daniel.moth@microsoft.com. So thank you for staying with us and enjoy the rest of the conference. Thanks.